Alright, first problem, all we have to do is cross multiply. So we're going to get 9 times 52 equals, this is going to be 39x minus 156. Okay, this is basically just a two-step equation. When you multiply, add this over to this, we should get 624 equals 39x. X is going to end up being 16. Okay, so x will be 16 for us on this problem. Again, you just got to remember to distribute the 39 to the x and the negative 4. Alright, if I'm going too fast, you can always pause the video when you're at home. Okay, this is a problem that's causing a lot of kids some problems, but what we have is we have two similar triangles. The way I know they're similar is because they have two congruent angles. Whenever you have a picture like this, I call this the inception picture. We have a triangle within a triangle. The best thing to do is to separate them. So if we can, draw two separate triangles. Okay, and by doing two separate triangles and labeling their parts, it's going to be easier to set up that proportion. So the smaller triangle is going to be 15 to 20. The larger triangle is going to be x to, this is going to be 6 plus 15, which makes 21. Now that I have my two triangles separated, I can set up a proportion much easier, right? Okay, I can go 21 to x, or 15 to 20. And that's how I'm going to set this one up. So 21 over x equals 15 to 20. See how I stayed consistent? So I went top to bottom of the big triangle, then top to bottom of the little triangle? Okay. You do your cross multiplication, you get 28 for x. Okay. Alright, number 3 was a tricky one in the way that this statement up here was incorrectly done. So we're going to actually just treat this problem as if they're in corresponding order already. So like 15 is going to go to x. So I can write 15 to x equals 9 to 3. Well, you soon figure out that these two triangles have a ratio of 3 to 1. Correct? In fact, the bigger triangle is 3 times as large, right? 9 versus 3. So I multiplied the smaller triangle by 3 to get it to 9. Okay, so basically what's x going to be? Well, if I multiply to get bigger, I'm going to divide to get smaller. So x should become 5. And if this is smaller, I got to make it bigger. I got to multiply 4 by 3, and I get y equals 12. So those are my two answers. Again, I could set up proportions and solve them. That would work as well. Or I can understand that I have a ratio here of 3 to 1. And I can use that to solve my problems. Okay. Number 4. It says use 3 postulates and theorems used to prove two triangles are similar. Okay, so we have angle, angle, side, 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 and side, angle, side. Those are the 3. Okay. Those are the 3. Remember, when we're talking about similarity, the angles have to be congruent, but the sides only have to be proportionate. Okay? Let's take a look at that and what I mean by that in number 5. Okay? Number 5, I have one congruent angle set right there, but I don't have any other angles. So I can't prove this by angle, angle. I don't have all 3 sides, so I definitely can't be side, side, side. My only hope is that this is side, angle, side. And to do that, I'm going to see if my sides are proportionate. I'm going to take the largest on the left over the largest on the right. The smallest on the left over the smallest on the right. And if I reduce these, I'm going to get 4 over 3 and 4 over 3. Do those sound like they're proportionate? Do they have the same ratio? Yeah. And so this means I can prove this triangle by side, angle, side. The sides are proportionate, the angles are congruent. Flip it over. This one's really easy. This one's just angle, angle. We have 2 angles, they're congruent. Done. Angle, angle. Very, very easy. Okay? The next one, we got to see It's 11:28, everyone. We got to see if this one fits our pattern here, or do we have side, side, side? So we're going to go and put these in order here. So we're going to get 21 to 14, we're going to get 15 to 10, and we're going to get 6 to 4. And if you reduce all of these, what do you find out you get? 3 over 2, 3 over 2, 3 over 2. So this is proportionate. This is side, side, side. Okay? Any questions so far? All right. Number 8, we have another inception triangle. It means we have a triangle within a triangle. We want to kind of try and figure that out. The best method for us to do this is to go ahead and separate them. So take out the big triangle and the small triangle. The small triangle is going to have 10, 6. The big triangle is going to have 21 and 30. And we're trying to find AB, and AB is this piece right here. It's actually the right side of that small triangle. And what we're going to do here is we're actually going to go ahead and we can set up a proportion. We can say 21 to x equals 30 to 10. And if you cross multiply, you're going to get 80 equals the value of 7. Okay, that means 80 right here is 7 units. Which leads us with the question, what's DE going to equal? Well, if 21 is the overall length, 7 makes up part of it. If we subtract, we're going to get the final part, and that's going to be 14. Does this look like it's to scale? No. Yeah, 7 looks a lot bigger than 14. So this picture's not to scale. We can also tell that because the 10 and the 30 are not to scale. If that was true, the 30 would be 3 times larger, and it definitely does not look 3 times larger. Okay. Alright. A tree casts a 30-foot shadow at the same time a person who is 6 feet tall casts an 18-foot shadow. How big is the tree? So you got a tree. You got a guy right here who also has curly hair. We could name him, I don't know, whatever name. 30-foot shadow. This guy's got an 18-foot shadow, and he's 6 feet tall. How tall is the tree? We're going to set up a proportion. We're going to go x to 6. Oops, sorry. X to 6 equals 30 to 18. And just cross multiply that real quick. 30 times 6 divided by 18, and we get 10 feet tall. Okay. What is Pythagorean theorem, and when do you use it? It's like insulting our intelligence, isn't it? There it is. And when do we use it? To find sides of a triangle. Dun, da, da, da. When do we use it? We use it on problem 11. Okay? So we get 8 squared plus x squared equals 17 squared. Just do that real quick in our calculator. And we get what? 15? This next one here, we get 10 and 11. So that's going to be 10 squared plus 11 squared equals x squared. Again, just doing our calculator real quick. This time we don't get an even answer. We get x equals the square root of 221. We can leave it like that, or we can leave it as a decimal, which is approximately 14.86. Okay. Determine the following side lengths would create a right triangle. Keyword is right. So we got to use Pythagorean's theorem again. So we're just going to say 8 squared plus 10 squared equals 12 squared. This is going to become 164 equals 144. Is that true? Nope. 9 squared plus 12 squared equals 15 squared. Is that true? Yes, that one is. And then 31 squared plus 35 squared equals 39 squared. Is that one true? Alright, 14. We get a 20-foot ladder leaned up against a house, so we have a house. It's like a really tall house, I guess. 20-foot ladder. 9 feet away from the base of the house. How tall is the ladder reach? This is just Pythagorean's theorem. So we just get x squared plus 9 squared equals 20 squared. I think I did this problem already. So we get the value of x to be the square root of 319. Doesn't end up being perfect, but I believe it's around 17 or 18 about. Okay. Whew, I don't know if I'm going to get through them all. The first go. Alright, this is all special right triangles. This is in the x rad 2 position. So to find the x positions, you're going to divide 10 by 2, which gives you 5, and then multiply by rad 2. So there's my 2 answers. 16, 45. Opposite is 8. That's in the x position. So this is going to be 8, and this is going to be 8 rad 2. 17. This is in the 2x position. This is in the x position, so that's going to be half of that, which is going to be 9. And this is going to be 9 rad 3. I like these ones, huh? Aren't they fast? That's in the x rad 3 position. So to find x, I'm going to take 9 divided by 3 and then multiply by rad 3. That's going to give me 3 rad 3. And then for this, I'm going to double it and get 6 rad 3. This is just writing my sine and cosine ratios given angle A. Okay, so we're going to start looking at this position. We know SOHCAHTOA. Okay, so 12 is my opposite, 37 is my hypotenuse, and A is my adjacent, given angle A as my angle I'm looking at. And so we just have to fill it in. So would be 12 over 37. Ka would be 35 over 37. And TOA would be 12 over 35. Okay. 20. Given the triangle below, solve for x. We use this perspective right here. So we're given opposite and hypotenuse. We're going to use sine of 37 equals 23 over x. You guys recall your algebra skills? We can replace or switch x with sine of 37. They can flip spots literally. So we get x equals 23 over the sine of 37. When doing that, we just plug that into our calculator, which I think I've already done. And I got 38.2. Okay. The next one, we're given the perspective down here of the x. I have opposite and adjacent, so I'm going to use tangent of x equals 29 over 21. In this case, I'm just going to use the inverse tan. When we're taking a sine, cosine, or tangent of a variable instead of an angle, we have to use our inverses. So x is going to equal the inverse tan of 29 over 21. Okay. And I did this one earlier as well, and we got 54.1. Okay. And we're going to stop there at 21. We'll pick up 22 through 25 much later.